Well, welcome back. We are going to start Unit 1, Lesson 3 and 4 in just a few minutes, but I wanted to introduce you to a couple more different types of puzzles. These are called magic squares. A couple things I want to point out. You'll notice that they are 3 by 3s, and because they're 3 by 3s, you can only use the numbers 1 through 9 in each of the squares up there. So the 2 and the 9 on your left have been used already, and the 6, the 5, and the 8 on your right square have been used already. So let's just focus on the one on your left. And they're called magic squares because the object of this square is to try to come up with the magic number using the numbers 1 through 9. So when you add up the 2, the 9, and the next number, you get a number that is the same as when you add up the 8 and a number up here as well, as same as the 2 and the 8. When you add this third number in, the magic number, which is on the outside, is the same for the column, for the row, and for the diagonal. So take a look in your black notebook. Go ahead and write Unit 1, Lesson 3 and 4, and then draw this 3 by 3 um, square here. And if you would, please put the 2 and the 9 and the 8 in the correct spot, and then we'll get started here in just a second. So if you look at the first puzzle, you have 9 and 2. 9 plus 2 is 11. And then I look over here at the 8, and the 9 and 8 is used already. So I'm thinking that it's probably going to be a smaller number in this square here. Probably not a 7 because you already then used up the three highest numbers. So, I'd look at something like between 1 and 5. And then it's kind of a matter of almost guessing. So I'm going to guess and place a 4 in there. And then I'll add up the 2 and the 4 and the 9, and that equals 15. So I'm hoping that my magic number will be 15, but we'll see. So if the magic number is 15, then 4 plus 8 is 12. That means I need a 3 there, and that's 15 there. All right, so now I use the 2, the 3, the 4, the 8, and the 9, so I just have the 5, 7, 1, and 6 left. 8 and 2 is 10, so I would have to use the 5 for 15. 9 and 5 is 14, plus 1 for the 15. 3 and 5 is 8, and 8 plus 7 is 15. Looks like I picked the right one. 8 and 1 is 9, and 9 plus 6 is 15. Let's just double check. 4 and 5 and 6 is also 15. So the magic square number was 15. So let's look at the one over on the right. We've used the 6, the 8, and the 5. Again, 6 and 8, pretty large numbers when you can only use 1 through 9. So you're probably going to be looking at a smaller number right here. Go ahead and work that problem. I'll pause the video just for enough time that you think you might have the answer, then hit play, and you'll see if you're right. All right, so here we go. 6 and 8, and I'm going to place right here the number 1. 6 and 8, and 1 is 15. Now, if I'm right, my magic number 15 has nothing to do with 15 over here. It just happens to be 15 if I'm right. All right, so 8 plus 5 would be 13. 13 plus 2 would be 15. So far, so good. 1 and 5 is 6, so I would need a 9 to make 15. So far, so good. You can't repeat any of the numbers between 1 and 9. 2 and 9 is 11, so I would need a 4 to make 15. 8 and 4 is 12, so I would need a 3. 3 and 5 is 8, and I would need a 7. And I've used the numbers 1 through 9, and my magic square number, just like the previous problem, was 7. So now you've done Magic square is quite fun. We'll do several, so we'll do them several times throughout the year. Let's go ahead and skip over to our first lesson. I'm going to move things around here. I think I'm going to make this full screen if I can. It didn't change. But let's bring it back. There we go. All right, so draw a line. Right, Unit 1, Lesson 3, rate situations and rate tables. And this is page 9, so please add that as well. So it says on page 9, find the total so far. Noreen started to save money. Every day she put 3 $1 coins into her duck bank. Write how much money she had each day. So she begins with an empty bank, and so she would have $0 in her bank. On day 1, she adds $3, so she would have $3 at the end of day 1. On day 2, Noreen put $3 in her bank. She had $3 from day 1. She adds $3. She's up to 6. On day 3, she adds $3 more. So at the end of day 3, she would have $9, and so on. All right, so on day 4, Noreen put $3 into her bank. If you recall, on day 3, she had 9, so 9 plus 3. So she'd have $12. Problem not 5 says on day 5, she put in 3 more. She would have $15. Day 6, she would have $3 more, so she'd be up to $18. So on day 10, so now we went from day 6 in problem 6 to day 10. If this pattern continued of adding $3 into her bank every day, on day 10, how much would she have in her bank? And day 12, how much would she have in her bank? So go ahead and day 6, she had 18. Day 10, what would she have? And day 12, what would she have? If you haven't done so already, write problems 7 and 8, and then solve that. So day 6, $18. Day 7 would be $3 more. 18 plus 3 is 21. And then day 8, day 9, and day 10. On day 10, she'd be up to $31. And then on day 11, she'd be 34. On day 12, she'd be $3 more. And your final answer would be $37. Now, one thing I hope that you picked up on, that was a constant rate. And here's a way to organize your data in a rate table. It says a 2-column table showing the number of units in the first column and the value associated with each number of units in the second column. When the units are listed as counting numbers in consecutive order, and this is the part that I want you to pay close attention to, consecutive order, the values in the second column will show a constant difference. This constant difference is the unit rate, and that's important because in your assignment at school, it's going to ask you if it's a constant difference, if it's the same unit rate. So this one says the rate table below shows how the unit days and the number of dollars saved are related. The constant difference is always 3, and the unit rate is $3 per day. So this is just a way of representing that data. So using that same rate table, um, it, it shows her savings. So what I'd like you to do is, in your notebook, we're now on page 10, so go ahead and make this rate table, day columns, a day column and a dollars column. And then you'll see that on day 1, $3, day 2, $6, day 3 would be another $3. So complete that table, and I'll go ahead and do it myself. So now we're up to 9, but it's a constant increase of $3. So I'm just going going to go down the line here. So 4, 5, 6, 7, and 8. 4 on day 4, up $3, 12. Day 5 would be 15. Day 6 would be 18. Day 7 would be 21. And day 8 would be 3 more, which would be 24. So, number 10, answer this question. What did you write between each row? And it would be a plus 3. And now problem number 11 says, what does the number between each row show you? And it shows you that it was a constant $3 increase. So constant it's hard to write with a mouse. Constant $3 increase. Oops, that was pretty bad. How about that? Arrow going up. That was interesting. There we go. Then decide, complete each table, then decide which tables are rate tables and which are not. You don't have to do number 12 here, but let's just take a look at it. Number 12 is 1 to 2, then it's going up 2, and it's going up 2 every time. So 2 up 2 would be 4. And then on day 3, up of 1 to 2, 2 to 4, and then day 3, we're at 6, up 2, day 4, 8, and so on. So over on the right, it says that this is a rate table because the table has 2 columns, and that the rows increase by the same unit rate, which is $2. Now look at 13. On 13, you have day 1, $4, day 2, $12, day 3, $18. So on day 1, it went up from 1 to 4. I mean, it's $4, excuse me. Day 2, it's now at 12, so it went up 8, because 8 plus 4 is 12. But now on day 3, it went from 12 to 18, which is only 6. And then from day 3, which is 18 now, because 12 plus 6 is 18, to day 4, which is 20, it only went up 2, and so on. So this would not be a rate table because the daily increase is not consistent. Let's look at number 14. Again, you don't have to do this, just take a look at it. 1 to 7, 2 to 14. From 7 to 14, it went up how much? 7. Then from day 2, $14. Day 3 is now $21. So that went up again, a plus 7. Now let's just do it one more time to see if it's still consistent. Day 3, 21. Day 4, 28. That would be a plus 7 again. So table 14 would be a rate table. The daily increase is consistent, constant. Both columns are from the multiplication table. Right. One more. Table 15. Day 1, $3. Day 2, $5 plus 2. Day 3, $5. So there was an increase of 0. And then day 3 is at 5. Day 4 is 9. So now it went up $4. So this would not be a rate table because the daily increase, again, is not constant. So hopefully you understand that to be a rate table, it has to be a constant rate. On page 12, we have some more factor puzzles very similar to what we did in lesson 1 and 2. And I'd like you to solve problem 16. So go ahead and in your notebook, write down 16. And then you have 32, 27, and 72 in your puzzle. Looking at the 27 and the 72, what factor would go in a 27 and 72? Hopefully you came up with 9. 9 times 3 is 27, and 9 times 8 is 72. Carry the 8 up, carry the 3 up. 32 divided by 8 is 4. Bring the 4 over. 4 times 3 is 12. And then you just solved it. Let's do number 18. So go ahead and work number 18. And now you have 24, 21, and 28. Focusing on the 21 and the 28. Looking for a common factor that will go into 21 and that will also go into 28. When you have that common factor, plug it in. 7 goes into 21 3 times. 7 goes into 28 4 times. Bring the 3 up. Bring the 4 up. 24 divided by 4 is 6. Bring the 6 over. 6 times 3 is 18. Hopefully that makes sense. And let's move on. All right, so your homework tonight, or excuse me, for during the school day, looks like this. I know it's kind of small, but you'll see it again tomorrow. This is the homework side, and we tend to do both the homework side and the remembering side. So it says, complete this story about Noreen's older brother, Tim. It says that Tim saved $5 every day. Noreen and Tim both started to save on the same day. Draw pictures of Tim's bank each day, if that helps you to decide how much he has saved. So if Tim began with an empty bare bank, on day 1, Tim puts $5 into his bare bank. On day 1, Tim has $5. So you'll put a 5 on the line. All right. And then you answer on day 2, Tim put 5 into his bare bank. On day 2, he has 10, and so on. Down below here, it wants you to complete the rate table to show Tim's savings. The remembering, you have several different types of problems. Multiplying and dividing. 56 divided by 8, 7, excuse me, is 8. Remember this is another symbol for multiplication, so this would be 9 times 9, which would be equal to 81, or so 81 equals 9 times 9. Remember, if it's set up like a fraction, it's a division problem, so number 12, 63 divided by 7 would be 9. Down below, number 16, we'll take a look at that. Represent the situation with an equation. So it says, Marcy plants 42 tomato plants in 6 equal rows. How many plants are in each row? So it wants you to write the equation and then also solve it. So she has 42 tomato plants in 6 rows. How many plants are in each row? So there's 2 ways you could set this up. 42 divided by 6 equals, and we'll just say equals n. That's one way. You could also say, let's see, I could put this off to the side. 6 times n equals 42. And hopefully you know that 6 times 7 is 42, so there would be 7 plants. All right, so you do 17, 18, 19, and 20 exactly the same way. All right, let's move on to lesson 4. So draw a line in your black notebook, and lesson 4, rate situations and unit rate language. Number 1, rates and multiplication. It says Pedro and Pilar collect snails. Each day they add 4 snails to their tank. How many snails do they have after 5 days? So again, over on the right, they want you to complete this unit rate table. Day 1, 4 snails. Day 2, 8 snails. Day 3, day 4, day 5. Then they want you to answer how many snails do they have after 5 days. So over on the right, if they have 1 to 4, 2 to 8, what would 3 be? 3 to 12, 4 to 16, and 5 to 20. And it went up by 4 every time. So go ahead and make this rate table. And then over on the left here, they have you multiplying 2 times 4. Then the next one would be 3 times 4, 4 times 4, and 5 times 4. So the answer over here would be 20 snails. All right, number 2, we can make a rate table to find the answer for any of the, so that's what we just did there. So, and then number 3, where in the rate table is the answer to the problem 1, and why is it there? Well, it's in the 5th day, because that's what is set up in the problem. So you don't have to do number 3, but it says where's the rate table? Where in the rate table is the answer to problem 1, and why is it there? It would be at day 5. It's the total number of snails collected after 5 days. So it's this right here. All right, let's take a look at the definition again of a unit rate is the value associated with 1 unit. For example, 5 miles per hour would be a unit rate. $3 every week, 2 apples each day. And in that constant rate, to be a rate table, the rate has to be constant. In a rate table in which the units are consecutive whole numbers, the constant difference in the value shown in the second column. Also the value in the second column when the number of units equal 1. So unit rate, what I would like you to do is, you don't have to copy the whole definition, but copy this one example. So equal groups, multiplication, and rates. A rate problem can be thought of as equal group multiplication. The multiplier is a unit that counts the number of groups. A unit rate is the amount in one group. So the number of groups times the amount in one group equals the total. Multiplier times the unit rate equals the product. Number of days times 4 snails each day equals the total number of snails so far. If the same rate is repeated, it has a constant rate. Look for special words that show a constant rate. For example, the rate is 4 snails every day, or the rate is 4 snails each day, or the rate is 4 snails per day. So those are kind of clue words. All right, let's look at page 14 in your black notebook then. Write down problem number 4, and it says identify rate situations. For each situation, decide whether there is a constant rate. If yes, write the rate and complete the rate table. Okay? So number 4, in the zoo, 7 kangaroos live in each kangaroo house. Is there a constant rate, yes or no? And then if there is, complete the rate table. So first of all, 7 kangaroos live in each house. So would that be consistent? Again, you're looking for kind of those code words like each. So is there a consistent rate if 7 kangaroos live in each house? The answer would be yes. So for number 4, write yes. And if that's the case, you would complete the rate table. So it'd be 7 kangaroos per house. The unit rate would be houses. Oh, excuse me, the unit would be houses and kangaroos. All right, and then we have 1 to the 7, 2 to the 14, and 3 to 21. Increase of 7 plus 7. Okay, let's look at number 5 now. In the last 3 weeks, Ben saw 3 films, then 4 films, then 3 films. Is there a constant rate? So number 5, hopefully you said no, and then you don't have to do the rest. More problems the same here. And then let's take a look at your homework assignment, or your assignment that would be to be completed in school. All right, same thing. For each situation, decide whether there is a constant rate. If yes, write the rate and complete the rate table. Grandma Jackson has 5 plants in each row in her garden. Is there a constant rate? Hopefully you would say yes. And then you would complete 5 plants per row. On the unit and product column, you would have rows, pretty small for me, and plants. One row, 5 plants. 2 rows, 10 plants. 3, 15, increasing by 5, increasing by 5. All right, so then 2, you do the same thing, decide if it's a rate table. Number 3 is asking you to write a story for this rate table. Label the columns to tell your story. And then you're using the information right over here to write your story. And then number 4, 5, and 6 are factor puzzles. And then the remembering piece, more factor puzzles. Let's just do one real quick. You have 10 and 8, 15, 10 and 8, common factor. 2, 2 times 5, 2 times 4 is 8. Bring down to 4, bring down to 5. 15 divided by 5 is 3. Bring over the 3. 3 times 4 is 12. So that's how you complete that. 7 through 11, they want you to write the equation and then solve it. If Maria places 40 roses equally into S vases, how many roses will she put in each vase? So again, you have into 5 vases, not S vases, into 5 vases. So how many vases will she put in each row? You have 5 times n. You can just write 5n, and n is your variable, equals the 40. Or you could say 40, oops, I can't write over there. And put it up there. 40 divided by 5 equals n. And then your answer should be 8 roses. Okay. All right, we've completed lessons 3 and 4. In school, you will get a chance to finish the homework and the remembering page.